Hello dear friends, myself Sonigra, and today we are going to discuss about details in assembly drawing in the subject of mechanical drafting. Last time we discussed some of the problems related to detailed drawings as well as how to assemble them and how to show all the components, their relative positions in assembly drawing. Which details are included in detailed drawing and which details are to be written on the assembly drawing that we discussed in the previous session. In this session we will discuss how to draw the assembly drawing of given details of the component, the importance of the assembly drawing, importance of detailed drawing, and what are the typical examples based on industrial applications. Today we will discuss about how to draw assembly drawing from given detail, how to draw detailed drawing from assembly, and how to prepare the bill of material as well. So these are the objectives of today's discussion, which includes the preparation of bill of material. What is detailed drawing? It's a working drawing, a drawing that supplies information and instructions for the manufacturing or construction of machines or structures. That is working drawing. And detailed drawings provide the necessary information to manufacture various parts, and assembly drawings supply the necessary information for assembly and the relative position between each component on the drawing. Detailed drawing requirements. What is required to draw the detailed drawing? That is shape description. Select number of views to describe the shape of the parts, size description, dimensions of the object, specifications, that is material, finish, that is surface finish, tolerances, additional drawing information like drawing number, scale used in the drawing, method of projection, whether it is first angle projection method or third angle projection method, date on which it is drawn, name of part, drafter's name, who has drafted that component, the name of designer, the name of the person who is checking or who has checked, name of the person who has approved the drawing, and sometimes revisions also. These are the given on the detailed drawings. Details must have a thorough understanding of materials, shop processes, manufacturing methods, the type of manufacturing process, because the type of manufacturing process influences material selection and detailed features of a part. Multiple drawings or multiple detailed drawings can be shown on one or multiple sheets. Generally, detailing is often grouped by the department in which they are made. For example, electrical transformer, which includes various types of parts, wood part, fiber parts, metal parts, etc. Separate detail sheets for each shop and one for assembly. Identification part numbers are shown on the detailed drawing. This is typical detail and assembly drawing of cover plate. You can see here, this is the title block of this cover plate. In this cover plate, here 12x 30 degree means at an angle of 30 degree 12 components are there. Is this one, that is circular hole, and circularity of this hole is mentioned as 0.005, or ovality should be within this limit, and the diameter of this pitch circle diameter is 5.9, and unless the specified surface finish is this one, B63, and the symbol is drawn over here. These are the symbols to represent the circularity. This shows the parallelism of this surface with respect to A. This shows the circularity of this 4.7 diameter with respect to B. And here the third angle projection method is used in this drawing, and revision is not made till date in this drawing, so which is not written over here, revision 1, 2, 3 onwards. It is not written, hence it is not revised drawing. Name of company is mentioned over here, name of the component, that is cover plate, material required is this one, number required 4 quantity of this component is required, checked by this person, and on date this. So this is typical simple detailed drawing. Now second, detail and assembly drawings. Casting component is here. So here surface finish is not much finer, it's a coarse surface finish. It could be seen over here. These symbols represents the surface finish. The dimensions are inserted at almost every places, and this cross section is elliptical cross section, which is shown here by this ellipse. Here manufacturing process influences the shape of the part, which is shown over here. Dimensions are written with the tolerances. Here this diameter is 0.936 to 0.93, height and all the parameters are mentioned in this detail. Dotted lines are drawn over here, which shows it's a circular hole which is made throughout from upper edge to lower edge. Next drawing, this is the typical drawing of connector details. Details of various parts are there. Many parts are drawn over here and detailed drawing is shown over here. Then drawing revisions. What do you mean by drawing revisions? Revisions are made to an existing drawing when manufacturing methods are improved to reduce the cost, to correct the errors, and to improve the design. Whatever alteration are made in the existing drawing, that is to be shown with the help of revisions. A clear record of these revisions must be registered on the drawing with date as well. The revision table should be on the old drawings. Numerous revisions often leads to a new drawing, so it should be redrawn and revised. Assembly drawings. Assembly drawings are drawing that show the product on its completed state. Design assembly drawing, it shows the performance, shape, clearances of the various parts shown. Installation assembly drawings, catalog assembly drawings, item list or bill of materials, or it is also called as BOM, itemized list of all components shown on the drawing. So these all are included in assembly drawings. Now one screw jack. Here we will see how to draw assembly drawing of the screw jack, what is the details of screw jack and how they are assembled together with a video clip. As we know, screw jack is used to lift the heavy load with the help of less effort.
Many times in engineering machine drawing, students feel it a bit difficult to see when different lines are visible and when some of the lines in the assembly drawing are going to be hidden. See, the first step in a machine drawing, any machine drawing assembly, is to know how to make sections in different views. Sometimes the views will be already given in the sections, whereas at other times the section will not be given. A complete 360-degree diagram will be given, which we have to first section, imagine how the section will appear, and then draw it accordingly. So this is a machine drawing question wherein we have a question on screw jack. All the details will be given like this. And one by one we have to assemble these different parts and draw its assembly in half sectional view. So I have already developed this drawing in 3D just to give you an idea about how the different views are going to appear. So this you can see is the front view wherein half the part has been sectioned by half amount. You can see on the side the part which is being removed. So just I'll give it a slight rotation so that you can have a complete view and understand how the different parts have been separated. So this is how we develop half sectional views. Coming back to the front view, let us have a look at the details here. At this part, when we see the bottom part, the part in the red is this part over here, the part number 1, which is shown in section. That section appears like this. Inside that, this part, the part number 2, is going to be inserted, and inside that, here there is a square thread connection between these two, wherein the helical square thread is going to be wound over this part, the part in green, as well as inside the hole of the part which is in blue. So they are going to mesh with each other, so that when this rotates and this is stationary, there is up and down movement occurring for this rod. Further going upwards, we see here that this part is inserted. This part goes inside completely, but we just have to show half sectional view. That means only the half part of the screen will appear in section. The remaining is full. Going ahead again, this green part is going to come out of here, out of this part here. Giving it a slight rotation will make this clear. So you can see this green part is coming up and this blue part is resting over it. And to fasten this blue part with the green part, we are using a red screw over here. This yellow part is going to be the part which is going to hold any of the object which has to be lifted. Coming back to the total view. Now this same view has to be drawn from top. Usually they are going to ask you to draw a view from the top. But while drawing the view from top, you should not draw it in section. You should draw the complete part of it. So let me just move this part back to where it belongs, and then let us have a look at how the object appears in top view. So you can see here the yellow part is going to appear first. Fine. The red part here, it's going to be visible, blue part, and then the yellow part. After that, a part of this sky blue part is going to appear, but this blue rod is above the part, so this has to be drawn first, and later on, if any lines are left, you have to draw the blue part. And finally, the last circle, the outermost circle, is going to appear. So the part will be appearing like this. So when you have a look at the isometric, we'll get the different views. This is the front view with all the parts mentioned. You can see there are different colors. So some of the lines have to be removed, which actually are appearing in the drawing. Like for example, this line here, the line in red, it's going to be coming out of the intersection of this vertical line and the line which is parallel to this slant edge. They are going to intersect here. From there, an edge is going to appear. So that will be hidden behind the green part, and so accordingly we have to show it behind it. That apart, here at the top, this red screw is going to be inserted. This green part here, it has to appear here, and accordingly you have to draw it. So when we finally develop the drawing, it's going to appear somewhat like this. So let us have a look at different parts one by one. So this is how the parts are going to appear. So the lines have to be dark, the hatching lines have to be light. One by one the different parts will be like this. So you can see how the part is going to be present over here. Front part completed. We can go for the top view here. So while drawing the top view, we have to take some things into account, like this part over here. So first I told you that the red screw is going to appear, and outer side that we are going to have the blue part. After that we will be having a yellow part, and this green part is going to be visible only to a small extent. So you can just have a look at the 3D diagram can see at this part over here, a small amount of this green part is visible, the green part, and here we have the semicircular cuts which are going to appear like arcs.
So now we discuss one detail in assembly drawing of floor stand grinding machine. This is the assembly drawing of floor stand grinding machine taken from Timken Roller Bearing Company. Here these are the components, 13 components are assembled together, and here you can see no any dimension is inserted in this assembly drawing. Only number of components are mentioned, that is 4, 5, 6 onwards, and name of each component is to be inserted in the bill of material only. On assembly drawing it's not needed to insert the name. Section lines are drawn to represent and to distinguish various components from each other. As you can see here, a hole is there, so that hole is not represented by dotted line, but it is represented by cutting section line and full lines. Similarly here section lines are drawn in this 5 number component. Now we will see steam engine cross head assembly. In steam engine, cross head is used. How it is assembled, that we will see here. See, this is nowadays these steam engine are not used, but as far as the syllabus of this subject is concerned, this question is asked. Let me make assembly of this steam engine cross head. So for that we will call each component one by one, assemble them together, and we will see how the cross head of steam engine works and how it is manufactured and assembled from individual parts. So this is the assembly drawing. These are the parts. Part number 1, this one block, that is named as block, so we call this